Projectile motion is a very common application of quadratic equations and quadratic functions. Projectile motion just simply means that we've set some sort of object into motion. You might shoot a guy out of a cannon, or you might lob a ball up into the air. In this case, we're going to climb up to the top of a building and we're going to throw a ball up into the air. We know that what will happen to that ball is that it will go upwards for a while, and then because of gravity it will turn around and come back down and eventually hit the ground. And there's two things that we might ask about that ball. First of all, how high did it actually get? And second of all, how long is it going to take before it hits the ground? So we have this expression, this function rather, that represents this ball in motion. H of t is the height of our ball after t seconds, and t is the number of seconds it has been since we've thrown the ball. We also need v0 in our function, v0 being the initial velocity, so that's how fast it was traveling when you first threw it, and your initial height. So for this problem, we'll let the height of the building be 200 feet. And let's say you were able to throw that ball upwards with an initial speed of 96 feet per second. So if we rewrite our function using these numbers, we get h of t, again the height at any time t, is equal to negative 16. Now you might wonder where that comes from. That's actually a constant based on gravitational force. Plus, and then we have to take our initial velocity, 96, times t, and then finally our initial height. Now, to figure out, or to see how we're going to figure out how high that ball got, if you can imagine this on a graph, we're going to let time be on the x-axis, and the y-axis is going to be our height. So imagine we're starting here at a height of 200, and we know that at the beginning our ball is going to increase in height, and as we said before, then it's going to turn around and decrease and at some point hit the ground. We know that quadratic functions graph as parabolas, and in this case we have an upside down parabola. And the thing that we know about upside down parabolas is that the highest point is right up here at the top of the arch. Right there. And that point is the vertex. So if we could find the coordinates of the vertex, that will tell us how high our ball got. We know how to find the x-coordinate of the vertex, and remember x represents our time. The x-coordinate, there's a little formula for it, negative b over 2a, and b is 96, so we have negative 96, and a is a negative 16, so 2 times a negative 16 is a negative 32. So when you simplify that, our time is equal to 3 seconds. So now we know how long it took to get to the maximum height, but what is that maximum height? Well, now we need to evaluate our height function when t is equal to 3. So we plug in our 3 and we proceed to do the arithmetic, and when you crunch your numbers, what you get is that the height when t is 3 seconds should equal 344 feet. So that's how high your ball got. Now the second question that we might ask is, okay, well we know how high it gets, but how long did it take for this ball to hit the ground? So we want to know how long it took. What is the value of t when our height is 0? So we have this quadratic equation then that we need to solve, and we have several methods that we could try. I'll just try with the quadratic formula. Now, I don't like the fact that those numbers are so big, so I'm going to go ahead and factor to get my numbers a little bit smaller. So I'm going to factor out a -8. That's about the biggest thing that I could factor out here. Oh, and sorry here, that plus should be a minus 25. So let's plug those numbers into our quadratic formula. We have a is 2, b is a -12, c is a -25. So our quadratic formula says x, which in our case, remember, is our time. So we have a -b plus or minus radical. We're going to take our -12 and square it. And then minus, so remember we're going to multiply 4 times 2 times a -25. And all of that is all over 2 times a, which is 2 times 2. So simplifying all of that, we get 12 plus or minus, and then our radical simplifies to 344 all over 4. Now this radical, since we're looking at a practical problem, we're going to go ahead and find an approximate answer for that. So if you plug that into your calculator, you should get something like 18.5. Remember, we have two solutions embedded here. We have 12 plus our 18.5 over 4, and we have 12 minus 18.5 over 4. So 12 plus 18.5 over 4 calculates out to 7.6. And when we start to do our calculation for 12 minus 18.5 over 4, we see that we're going to end up with a negative number, and since we're talking about time, we definitely do not want negative time. So we found our answer. 7.6 seconds is how long it takes that ball from the time you threw it to go up and then turn around and go down and finally hit the ground.